Hello, today we're going to cover our second lesson on energy levels inside atoms. We're going to start by describing what ionisation is, and then we're going to talk about how energy changes in atoms occur due to collisions with those atoms. We're then going to use that information to explain the functioning of fluorescent lamps. To begin with, ionisation is a simple process whereby electrons are completely removed from atoms. For example, a photon with sufficient energy absorbed by the electron will cause it to be ionized or removed from the atom. The energy necessary to ionize an atom is given by the magnitude of the energy of the ground state. For example, we have the energy level structure of hydrogen shown. For hydrogen, it would take 13.6 eV to remove an electron completely from the atom. To remove an electron from the atom, we must move it or excite it to the n equals infinity energy level. At this energy level, the electron has 0 electron volts. Therefore, if we're going to ionize an electron which is in the ground energy level, we would need 13.6 electron volts to completely remove it from the atom. Here's a quick question for you to have a go at home. Pause the video and write down what you think the difference is between excitation of electrons and ionization of electrons. I'll come back to with the answer in a moment. So, in either case, an electron receives the exact amount of energy that it needs. However, during excitation, the electron simply moves up an energy level, whereas during ionization, the electron completely leaves the atom. So far, we've discussed ionization and excitation in terms of the absorption of photons inside atoms. However, there's another way these processes can occur. Instead, an external electron can collide with an atom. This electron, assuming it has sufficient energy, can cause electrons inside the atom to become excited or even ionize completely from the atom. While the electron must have sufficient energy to excite the electrons inside the atom, any excess energy will be kept by the original electron. Let's go through an example. An electron of energy 2.5 times 10 to the minus 18 joules collides with a hydrogen atom that is in its ground state. It excites the electron in the hydrogen atom to the n equals 3 level. The first part of this question asks us to calculate the energy that is needed to excite an electron in the hydrogen atom from the ground state to the n equals 3 level. If you feel confident, you can feel free to do this question yourself. Very simply, we calculate the energy that the electron gains as it moves from the n equals 1 to n equals 3 level. The difference in the energy levels of these two levels is 19.4 times 10 to the minus 19 joules. The second part of this question is slightly trickier. We're asked to calculate the kinetic energy of the incident electron after the collision. If you'd like to have a go at this yourself, pause the video now. The first thing that we need to recognize is that the incident electron has an energy of 2.5 times 10 to the minus 18 joules as it comes into the atom. However, once it collides with the atom and excites an electron inside the atom, it loses the equivalent of 19.4 times 10 to the minus 19 joules. All we have to do then is take the difference in these two numbers to calculate the final energy of the incident electron. The difference in these numbers is 5.6 times 10 to the minus 19 joules. Finally today, we're going to discuss the functioning of fluorescent lamps. These are a type of lighting which are an alternative to older-fashioned incandescent bulbs, which tended to have very low efficiencies. The functioning of fluorescent lamps takes place in several stages. Firstly, free electrons inside a glass tube are accelerated by a high voltage placed across the tube. Inside the tube, there is also a mercury vapor. These electrons will collide with the gaseous mercury, causing electrons in the mercury vapor to be excited. When these electrons eventually fall back down to the ground state, they will emit ultraviolet photons. Ultraviolet light is, of course, not visible. However, the photons are converted into visible light by a phosphor coating on the outside of the tube. The phosphor coating absorbs the ultraviolet light, exciting the phosphor atoms, and when these atoms de-excite, they emit visible light. Here's a final question for you to try. Pause the video and try and answer the following questions. I'll give you a few seconds and then I'll come back to you with the answers. Here's the answer to the first question. Electrons passing through the tube collide with the electrons in the mercury atom. They transfer energy or gain energy from the collision, and that causes the orbital electrons in the mercury atom to move to a higher energy level. The second question. Excited electrons relax to a lower energy level. As they do this, they emit a photon of energy equal to the energy level difference between the levels. The coating absorbs UV photons, which causes the electrons to become excited. These electrons then de-excite and in doing so emit lower energy photons.